Paired samples. How do we handle before and after data? In a paired design, each point in one sample is matched to a unique point in the other sample. Common designs include pre-test, post-test studies with the same individuals, crossover trials where each subject receives both treatments, and matched pairs studies. For example, the same subject is measured before and after. Each row forms a natural pair. The key to paired analysis is computing difference scores. Here is the oat bran study data. Each subject ate both a cornflake diet and an oat bran diet. We compute delta as cornflake minus oat bran for each subject. Positive values mean the subject had lower LDL cholesterol on oat bran, which is the desirable outcome. Notice most deltas are positive. The mean difference is 0.3725. with a standard deviation of 0.3908 and n equals 12 pairs. Here is the elegant insight. A paired t-test is simply a one-sample t-test applied to the difference scores. The test statistic is d bar minus 0, divided by s sub d over root, and the null hypothesis of no difference means mu sub d equals 0. Step A, h naught mu d equals 0 versus the alternative mu d not equal to 0. Step B, t equals 0.3725 over 0.1128, which is 3.3. Step C, with 11 degrees of freedom, the p-value is 0.011. Step D, since p is less than 0.05, there is significant evidence that oat bran lowers LDL cholesterol. We can also build a 95% confidence interval for the mean difference. The formula is d bar plus or minus t star times s sub d over root n, plugging in our values. 0.3725 plus or minus 2.201 times 0.3908 over root 12. This gives an interval from 0.124 to 0.621. On the number line, notice the entire interval is above 0. Since 0 is not contained, this is consistent with our decision to reject the null hypothesis of no difference. To summarize, paired data arises when the same subject is measured twice or when observations are naturally matched. The analysis reduces to computing difference scores and running a one-sample t-test on those differences. The null hypothesis is that the mean difference is 0, and the confidence interval for the mean difference shows the range of plausible treatment effects.